Hello everyone. Today I want to explain my homework 6.1. Uh, Write a LD to control piston with ejection planned by running timer 10 second counter 3 times. After that, model on and show float theme together. This report will be divided into 5 parts. First, we will clarify the objectives of the experiment. Second, introduce the hardware requirement and the connection method used in the experiment. Then we will disassemble the logic of each part of the render diagram program detail. Next, demonstrate how to perform a simulation in float theme. Finally, summarize the entire experiment. The core objectives of this experiment are fourfold. First, we need to master the timer and counter instructions, which are very basic and important in industrial control. Second, understand the control method of sequential logical through practice. Third, improve our ability to program and debug using ladder diagram. Finally, and most importantly for this experiment, is to realize the PLC control of the sonometric device and verify our design through simulation software. The hardware required for this experiment includes oblong PLC cylinder, solar driver, limit switch, motor for electrical connection. The output signals of the PLC control the solar drivers and the motor. First, phonometric connection. We correctly connect the solar driver to the cylinder according to the phonometric circuit diagram on the right to achieve the telescopic action of the cylinder. Now let's look at the first part of the ladder diagram. The timer logical. The time instruction is used here. Numbered 00000 with a set value of hash 0100. This set value responds a delay of 10 seconds. When the input condition 200.000 is turned on, the timer starts countering, and after 10 seconds, the timer contact T00000 will close to provide a trigger signal for the subsequent counter. Next is the counterpart. The CNT instruction is used here, numbered 00000 with a set value of 3. Its count input is formed from the content T00000 of the timer. Each time T00000 closes, the counter decreases by 1 byte. When the counter decreases from 3 to 0, the counter contact C00000 will close. At the same time, I0.05 is the reset signal, which can clear the counter and restore it to the integer set value of 3 at any time. The last part is the output control logical. After the counter complete 3 counters, contact C400 closes, triggering output Q100.04 to start the model. At the same time, the timer contact T400 will also cooperate with other input signals such as I0.03 to control Q100.02 and Q100.03, thereby driving the soldered wheels to control the acceptance and the retraction actions of the cylinder and complete the entire injection process. To verify our program, we use Fluxtherm software for simulation. First, build the same photometric circuit as the experiment in the software. Then, connect Fluxtherm with the PLC programming software through OPC or DBE, mapping the PLC's output signals to the soldered wheels in the simulation software. Finally, run the simulation and we can clearly see the calendar acting according to the logical we set, thus verifying the correctness of the program. Through this experiment, we successfully completed the automatic control task of the piston ejection device. We not only deeply mastered the use for timers and counters, improved our render diagram programming skills, but also verified our design through Fluxtherm simulation, gaining a more intuitive understanding of mathematics systems. This lays solid foundation for us to carry out more complex instruction control project in the future. Let's look at this video. That's it, all my homework 6.1. Thanks for your listening. See you.